Hello again, everybody, and welcome to video 3 in our right triangle trigonometry series. Today we're going to introduce two new ratios, the sine and cosine ratios, and we're going to concentrate on finding angles with them. So here are the sine and cosine ratios. For the sine ratio, sine from angle theta, remember theta is just the angle you're working from, it's just some general angle, a non-specific angle. And for this ratio, for sine, we always compare the length of the leg opposite the angle theta, or the given angle, compared to the length of the hypotenuse. Cosine ratio is the length of the adjacent leg. The length of the leg adjacent angle theta compared to the length of the hypotenuse. So they operate just like the tangent ratio. The only difference is they're different comparisons. So in tangent ratio, if you remember, we're comparing the opposite with the adjacent legs. So now we're not comparing those two. We're comparing in sine the opposite leg in the hypotenuse, and then in cosine the adjacent leg in the hypotenuse. Everything else, though, once you've plugged this in, everything else will operate the same. So really, I don't have too much to show you today. Okay, so let's get right into things. And in the first example, let's just set up these ratios. So we're just going to practice picking out the proper sides and putting them in the ratio properly. So we're going to look at sine first and sine D. So we're working from angle D. Remember, you always need to kind of clarify what angle you're working from first. And again, so this is that non-specific theta, right? So theta represents whatever angle you want to plug in. So now we've replaced theta with this D up here. Okay, anyway, so for sine ratio, we always compare the opposite leg with the hypotenuse. So the opposite is across. Oh, I'm sorry, my pen kind of went haywire there. Is the across, so I'd have 5. And then the hypotenuse, that is always across from the right angle, so that would be 13. So the sine ratio from angle D is equal to 5 over 13. You could convert that to a fraction if you wish, but you don't need to. Okay, let's look at now cosine. Cosine of D. Now I didn't write down it with the with sine, I didn't write out, but this would be the adjacent over the hypotenuse. You could even just write A over H, whatever you want to do to kind of use as a memory trick. But anyway, the adjacent leg is going to be 12, and the hypotenuse is the same thing as 13 again. So the cosine ratio from angle D is 12 over 13, and again you can compare that to a decimal. What that tells us is based on that value, that 12 over 13, there is only one size of angle that D could be. All right, so right triangles, if you remember, they're super predictable, and for every ratio you get a unique angle size. So based on this 12 over 13, if we check the chart or we plug it into a calculator, it'll spit out one angle and one angle only. Okay, let's keep going here. New triangle. So sine G, that is opposite over hypotenuse. So G is right here. Again, opposite is across, so that's going to be 8. And then the hypotenuse is always across from your right angle. So that is 17. It's also the longest side, so you can just use that. But that is the value of the sine ratio from angle G, just 8 over 17. So if they ever ask you to find the value of the sine and cosine ratios, all you're really doing is setting up this fraction. Cosine G, adjacent over hypotenuse. So the adjacent again is the leg right beside. And again, the reason it's not 17, it's 15. The reason it's not 17 is because 17 is the hypotenuse. It's not a leg. So it's going to be 15 over 17. And just in case you forget that stuff, guys, remember, this is a leg, this is a leg, this is the hypotenuse. So we'll never choose a hypotenuse when we're supposed to be choosing a leg. So that's why I would always choose the 15 in that case, because I'm looking for the adjacent leg. And the 17 is a different type of thing, right? It's a hypotenuse. Okay, in our second example, let's calculate the measure of the missing angle. So now let's go further than just simply setting up the ratio. Let's now find that angle. And like I said, based on the ratio, that'll tell us what the angle has to be. Okay, so in this, I haven't told you if you're going to use sine or cosine, so we're just going to kind of see what the drawing gives us and use the appropriate one. So angle G, so there's my G. Now I'll take stock of what I have. I don't have the opposite. This has to be, oh, I've noticed one thing, and you may have noticed it already. I forgot to put my right angle sign in there. There's my right angle, everybody. Back to the question. Seeing this is my hypotenuse, I know this is my hypotenuse, then I know this must be my adjacent right here. It's right beside. So adjacent hypotenuse, which ratio is that? That is the cosine ratio. So it's going to be cos G equals, and again, adjacent over hypotenuse if you want to do that. I'm going to write cos G again. Equals the adjacent, which is 6, over the hypotenuse, which is 14. Okay, now how to find the angle? You do the exact same, or use this exact same technique that you used in the tangent ratio. So to find angle G, we write cos to the -1, which means inverse cos, which is really just telling our calculator to go the opposite way on the chart that's programmed into it. And then again, we've talked about the calculator. You need to get one calculator, and you need to not lose it so you can learn the logic of that calculator, like the sequence of how to key things in. Because calculator to calculator, that changes. Anyway, however you do it, we've talked about before, you might go second function cosine, and then there'll likely be an opening bracket, go 6 divided by 14, and then you close your bracket, hit equals, or maybe you go 6 divided by 14 first, hit equals to get it into a decimal, then second function, then cosine, however your calculator works. Whatever you do, you'll get this answer, though, 64.62 degrees. And if you don't get that answer and you feel like you're doing the right thing, double check that your calculator is set to degrees and not radians. So we want it in degrees. All right, so once we've done all that, there we go. The only size of angle that could be G is 64.62. And how I know that is that if you have a ratio, if you compare your adjacent and your hypotenuse, and it happens to be 6 over 14, that's the only angle that that could be. Let's do B. So again, let's see what we're given. We're given angle K. All right, and then I can see right away this is an opposite. And then this is across my hypotenuse. This is my hypotenuse. So opposite and hypotenuse, that is sine. So sine K is equal to the opposite, which is 3, over the hypotenuse, which is 8. And then based on that ratio, I can figure out what that angle size is. So angle K equals inverse sine. Again, we're just telling our calculator, okay, go the opposite way that you're programmed. Usually the calculator is programmed to go from an angle size to this ratio value, but we're giving it the ratio value, so we're telling it to go back and find the angle size. And again, once you key that in, however you key that in for your calculator, you'll get 22.02 degrees. So these questions are pretty darn quick to do, everybody. Our third example, situational. So it doesn't have a picture, we'll have to draw it ourselves. A water bomber is flying at an altitude of 5,000 feet. The plane's radar shows that it is 8,000 feet from the target site. What is the angle of elevation of the plane measured from the target site to the nearest degree? All right, so whenever there's a description like this, what I highly suggest, you don't need to do it though, but what I highly suggest is simply draw the situation. So here's my right triangle, and here's a spoiler alert. We're dealing with right triangles the entire chapter, so it's always going to be involving a right triangle. Now, just to get kind of our bearings here, let's understand what's going on. This would be my water bomber up here, up there in the sky. I'll put a G for down here. This will be my ground. And I guess to use the questions language, I guess this would be the target. All right. Now, the assumption that you'll make in all of these questions is that the ground is always level. So right here, I'm going to draw this in red. Our height, by the way, a height is always vertical. If you think about when somebody measures you, you stand straight up, right? You never lean against a wall to get your height. You want to be as tall as possible, so you go straight up. And then right here, our ground's always going to be level in all these questions in your textbook, in all these types of right triangle questions. So that's one assumption you got to get straight in your head. Okay, so there is the outline of my question. Now I got to put some numbers in. The water bomber is flying at an altitude of 5,000 feet. So altitude simply means the height above the earth. So there's our 5,000. And then this radar shows that it's 8,000 feet from the target site. So we're talking about the plane itself. So the way we'll interpret this question is this will be 8,000. That's the way your textbook works, everybody, in this situation. I know it maybe feels like GT should be 8,000, but BT will be 8,000. And then what they're looking for is, what is the angle of elevation? So remember, angle of elevation is the angle looking up from a horizontal line. So it'd be right here. This will be our angle of elevation. Elevation, when we're looking up like that. Okay, so we're looking for angle T. All right, so once we know we're looking for angle T, Again, you've got to highlight your angle you're working from to kind of start naming the sides. I don't know why I said kind of start. It's exactly what you have to do. You name your angle, and you can name these sides. So this would be opposite, and hopefully you know that by now, and this would be a hypotenuse. So opposite hypotenuse, that's sine. And I'm working with yellow. I'm just going to go with here. Sine t is equal to then 5,000 over 8,000. And now you might be wondering, can you reduce fractions when you see that something that can be reduced? And absolutely you can. You don't need to reduce your fraction, but if you wish to reduce it, go for it. So if there's an advantage, do it. And I'd say there's an advantage. So like I'd way rather write just 5 over 8 than 5,000 over 8,000. So by all means, do that. Once again, you'll have to punch this into your calculator, and however you do that, you'll get 38.68 degrees. So that would be the angle of elevation in this question. Final example, just one more situational problem. Once again, you can see there's no picture. So the first thing I will do once I read this question is to draw a picture. And again, spoiler alert, it'll involve a right triangle. Anyway, an 8-meter ladder leans against a wall. The base of the ladder is 2 meters from the wall. Determine the angle of elevation of the ladder measured to the nearest degree. So we got to round this final answer here. So again, here's just my general right triangle. You could draw it in a different way if you want. If you want to have the different orientation, spin it around or whatever you want to do. Anyway, again, I think we should just kind of get our bearings here. This is this here will be our ladder. Okay, and then this here would be our wall, and this would be the ground. And you could, however you want to label things. So this could be, I guess, G for ground, but then I don't know what you want to name the ladder. So I'm just going to go A and B. I'm not going to overthink this. I know where everything is now. So it's an 8-meter ladder, so that means this would be 8. And the base of the ladder, the bottom part of the ladder, is 2 meters from that wall, so then that would be 2. And then we're looking for the angle of elevation again. So once I know we're talking about angle of elevation, I know right away it's got to be this. It won't be this guy because that's, I guess you'd be looking downward at that, but that wouldn't quite be an angle of decline either. I'm going to add something to this picture, just might as well talk about it. If it was an angle of decline, again, you need a horizontal line, and the angle of decline would be going down from here. So in this kind of shaded yellow area, that'd be an angle of decline. So we're looking for an angle of incline or elevation. So that'll be right there. So anyway, I'm looking for B. Okay, so I'm looking for this angle B. Now I can name everything. So this has to be adjacent because it's right beside it. And then this is across from my right angle. So that's my hypotenuse. So what has adjacent and hypotenuse in it? Well, cosine does. So again, you'll need to remember all that stuff. And I'll just write that out real quick just because it feels like I should. So anyway, here sine is going to be always opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent, what we dealt with in previous videos, is opposite over adjacent. And those ratios never change, okay? So you don't have to worry about that. Those are the 3 ratios you need to memorize. Back to this. We said cosine, right? So cosine of B, which is equal to the adjacent, which is 2, over the hypotenuse, which is 8. And just like in the previous question, I could reduce this, but really doesn't save me anything. So if you want to just write it as 2 over 8 or 1 over 4, it won't matter. And the reason it doesn't matter is that the decimal value is the same. 2 divided by 8 is 0.25. 1 divided by 4 is 0.25. It wouldn't matter what you use. Okay, so once you plug that in, you will get 75.52 degrees. And that would be the angle of elevation for this ladder, but they wanted it rounded, so sorry about that. I didn't round that. So 75.5, meaning I'd round that to 76 degrees. All right, so that's everything I have for this video. That was a lot quicker than those tangent ratio videos, but we had kind of a bunch of basic things to cover in those ones. I'm hoping you're getting the hang of this. The one thing that I know people are going to have trouble with is their calculator. So you may feel like you're doing this wrong, but truly you're just having issues with how to type things into your calculator. So if you feel like you're doing it right, but you keep getting wrong answers, talk to myself or your teacher. We'll get that calculator sorted out for yourself. All right, so otherwise, have a great night, everybody.